Hey everybody, so today I'm going to show you how to take a basic hobby servo and convert it into somewhat of a smart servo by tapping into the already existing potentiometer and getting positional feedback. So a little bit of a history here. I'm building a robot arm and I've been wanting to get, some sort of positional feedback without, complex, expensive actuators. And I know like smart servos like Dynamixel and some others exist out there. But I don't want to spend a bunch of money on just a servo just to do some, learning and playing around. So it occurred to me that I could just tap into the potentiometer already on this servo. So I'm going to show you how to do that. I'll share the code with you, and we'll go through it step by step.
All right, so what I have here is my basic hobby servo, a prototyping breadboard, and my Arduino. I'm using an Arduino R4 Wi-Fi edition. So what we're gonna do here is I'm gonna show you, just basic 3-pin wired to the power, ground, and pin 9 on my Arduino. A basic sketch that you can command a position and it'll move there. So if I say 0 degrees, it's already there. 90, we got 90 degrees there. 78, see 78, it didn't really move much. And the reason why is that we're not getting that positional feedback and the controller in these things aren't that great. So that comes into my problem, where I'm trying to control a link of my robot arm. I'm not really getting where I'm trying to go. So that's why what I've done here with this one already is I've tapped into the potentiometer. So let's open one up and see what's inside of it. All right, so just gonna grab the servo here. Brand new servo. Open up the package. What we got inside? Servo, some horns and things to mount the servo to something. So yeah, typically there's just 3 wires coming off these servos. You have your ground, your power, and your signal, which is a PWM signal that you would plug into one of the PWM signals on the Arduino. And you can see which ones are PWM by just looking at the little tilde next to the digital output. So, like I said, we're going to take this one step further and tap into the potentiometer. So, we're just going to take these screws off here. Take this out. Be careful, this is no longer being held on, so that can, all fall out. So inside you can kind of see, this is the control board for the servo. Then we have our motor, and then our 3 pins that come out for, controlling it and powering it. But back here we have 3 pins. So those 3 pins are to the potentiometer, and that's what we want to tap into. So the way most potentiometers work is that you're going to have power over here, signal, and then ground. And basically all a potentiometer is that, as power flows through, this middle one is the actual like resistor inside of the potentiometer as you turn it that gives that variable voltage coming in. So if you're putting 5 volts in and you turn that, you can get somewhere between 0 and 5 volts and read that. So that's basically, how this works. So we're going to tap into that middle wire there. Now, my soldering skills are not the greatest, especially on camera. So we'll see how this goes. But I already got a wire here prepped. And what I'm going to do is just solder right in there. This is not a channel to show you how to solder, so please do not pay any attention to what I'm doing here. I'm going to add just a little bit more solder. Careful not to bridge between the other pins. And that's it. So we're just tapped into that potentiometer signal. we're just going to come out with this wire with the other one. There should be enough room here. There we go. So now I will wire this back up and we'll run some code to show you some sort of positional feedback. All right, so to wire this up, it's just like any other servo. We have our power, our ground, and our signal. So I'm just going to match these up here. Got my grounds connected to the Arduino, important. My power supply, which I haven't really talked about, but I do have a little desktop power supply that's providing power to just the servo. It's not a good idea to power the servo from the Arduino. You can get by with it, but it's not good on the board. It's not meant to have that much of a current drawn. And then we have our signal here. So now the last thing is I'm going to tap this into an analog pin on the Arduino. So I'm just going to stick this in my breadboard. And then I'm going to jump from my breadboard over to A0. And I've got my servo horn here that I'm going to place on it once I figure out what the 0 degrees is. So now I'm going to upload my code. And we'll get the servo moving with some positional feedback. All right, so I've got the code uploaded, and I've got my wiper set here. So what we're going to do is I'm going to command a 90-degree move, and you'll see it kind of moves there with some acceleration and deceleration as well. Now, this servo controller is not great. I've been playing with it, and it can't seem to get to 180. Even if I commanded a 180 without the feedback, it just doesn't get there. So you're going to get this with these cheap servos. Sometimes these control boards inside here are just not good quality, and you're not going to get exactly where you've commanded. So it is what it is. So what we can do, and what I plan on doing in a future video, is actually taking the control board out of here and just using the potentiometer and the motor, and then using the Arduino to do the actual servo control to truly get a higher resolution and better position control on our commanded values. But still, out of the box, this servo is much more functional and responsive than what you'd get just plugging it in and trying to use it. The acceleration control is nice. And so yeah, I'll go over the code now, and we'll go over each line and what it's doing and how you can apply this to your application. All right, so here's the code. Basically what this code is just allows us to move to a specific point, and then it reads the analog signal to make sure that we get there, and then it's using some sort of smoothing so we get good acceleration and deceleration. So for all you fellow nerds out there, what this actually uses is like a trapezoidal velocity profile, reading that onboard potentiometer. If you don't know what that is, that's okay. Don't worry about it. Just use the code and you'll get good results. That's the beauty of YouTube. We can just take the code and then kind of modify it to how we know what we're doing, and just go from there and just kind of build from that. You don't have to understand every bit of this code to get it to work right. I'll kind of go over the main things you need to do to kind of change the way it behaves. And the rest of it, you can read the comments on your own. I explain it a little better. This video isn't about me diving deep really into how this code works. So basically at the top you got your configuration. So which pin is the servo plugged into for that PWM signal, and then your analog input for that potentiometer feedback, that extra wire we added. That's where this is going to go. And you can change these as you need if you don't have those pins available for whatever reason. And then these values here are what your A0 is going to read when it's at 0 degrees and then 180 degrees. So now with every servo, it's different. These things are not the same. I have two servos here that are very different values. So basically, you're going to move the servo to 0 degrees and have a little sketch that basically shows A0. I have something here that kind of does that. If it'll load, it's being weird. Gotta love it. Yeah, not gonna work. Why you do this? Anyways, a simple sketch just to read the A0, and I'm pretty sure there's actually an example to do this. If you go to like the basics, read analog voltage. There you go. We'll just go ahead and just open this up. So, using this example, what you're going to do is just read A0, and then it's going to give you the voltage. You can actually just take this out. I don't want that. I just want sensor value. So we just take that out, run it. So I'm going to actually send this over to my Arduino. We'll run this. Except we won't, because it's being weird. Well, you get the idea. No. So anyways, run that, and you'll get the A0 value. You can manually move the horn to what you want to be 0 degrees, read that value, and then move it to 180 and then read that value. And that's going to be your minimum and maximum here. And then, I've got some numbers here for the max speed and acceleration. You can play with these numbers. And then the tolerance, 1 degree, that's the best you're going to get with a servo like this. It's not going to be any finer than that. The servo controller on here is just not good enough. It's cheap. And, like I said, with a future video, I want to take that controller out and just do everything with the Arduino with the PID loop and actually get some positional feedback and get a better servo that's going to have much better accuracy than this. But this is still better than, what you get for $4 if you just buy it off of Amazon or whatever. So that's pretty much it. I mean, the rest of this stuff, this is the stuff that gets you to the position, checks the position, spits out where you're at and what you were trying to get to, and the speed and all that. So to command it, you just give it a degree. So if I just want 90 degrees, my servo just moved to 90 degrees, and it did it nice and smooth. And that's the point of this. We're getting positional feedback from that potentiometer and having some, nice fancy code around it to get there elegantly, if you will.
And that's it for this video. So thanks for watching. I hope you learned something. I hope you're able to take your basic hobby servo and do something cool with it. Get some positional feedback. Let me know in the comments what projects you're working on, what you'd hope to see from me. This is my first video on the channel, and I hope to do many more. I'm going to document, what I'm doing here. I'm making a robot arm using these basic servos as like a cheap robot arm that people can program, with the task of being something educational that people can learn from. So yeah, that's what I hope to do in the next coming videos. And if you want to see more, hit that subscribe button. I appreciate it. Thanks.